Hey, what's up folks, and welcome back to another layer by layer. In today's tutorial, we're going to take a look at the LED matrix project. This is a really fun one that I put together, and in this tutorial I just wanted to cover how I put together the snap fits. So this features a top and a bottom case, and they're very similar, and they have snap fits. So what I'll do is I'll use my spudger tool to pry this open so you guys can take a look inside of it. So I usually use my fingernails, but they're a little short this week. So I used that spudger tool, I popped it open, and let's take a look at the top cover. The top cover features these two snaps here. They are circular, and they kind of have that little Pac-Man looking shape to them. And on the inside here, you can see that the frame is fairly simple. Let's go ahead and pop this out as well. So this is a symmetrical design. It has nubs here on this surface, and then nubs on the opposite surface, and they're just mirrored from top to bottom, and then also mirrored from the left to the right. There are some these extra sweep geometry here. This is what actually keeps the covers and the snaps fixed in place. Normally, if you were to create a snap fit circular case and not have these sort of end stops, then what you'll have is this this thing that can kind of unlock itself by twisting it, and then it would open. And that could be interesting if you want to have that feature, but in this case, I did not want that feature. So you can see here on the inside, this sweep here does keep that snap with those edges locked in place, so it cannot freely spin now in there. And then this the bottom cover for this case has some holes here for securing the spindles to the cover, and then it has this sort of registration key here for this peanut-shaped enclosure for the matrices. So that's how that's working. And then on the inside here, a very similar type of feature, just a little bit different. This case here has like sort of a flat edge that allows the USB port to have a hole there and a little holder for the slide switch. So that's how that's working. All right, so we're just going to create this version here, this really simple case here, and show you guys how I create the sweeps there. All right, so let's jump into Fusion 360 and create a new document real quick. Folks, you guys can download the project file. I have this available to download in all the different file formats. It includes all of the electronics and the timeline, the sketches and everything. So if you want to get a look at that, definitely check it out. It is linked in the description. We also have a learn guide. So if you folks want to actually build this, you can purchase some parts from Adafruit. It'll help the whole team out, of course. And this learn guide walks you through all of the project, installing the code, the circuit diagram, wiring and soldering. All that stuff's covered here for you, so you can definitely build this out for yourselves. Again, links in the description for this one. Let's jump back into Fusion and create a new document. Let me close this document and start from this fresh one. All right, so the first thing I like to do is just create a new component. So you can do that several different ways. You can actually even do it in the shortcuts window. You just say new, and new component shows up. All right, the first thing I'll call it is enclosure. It will house all of the stuff that pertains to the enclosure. I have a hotkey set up for that, for the new component, so I'll just type that in. It's the letter N on my keyboard, but I set that one up customly. All right, so we're gonna name this one the bottom cover. Okay, I'll make a new component. I'll name this one case. I'm going to be careful here, see where it says parent. If I hit OK, it's going to make it inside the bottom cover, but I don't. I want it to make it inside the enclosure. So I'll hit X on that, and then this is selected, and I'll select the enclosure as the parent. I'll hit OK, so that way it stays within that enclosure. I'll create another one, and this one will be the top cover. And then again, I'll deselect the parent and then select the enclosure as the parent and hit OK. All right, so that's cool. Now I got my three things set up here, and I can start working away with the user parameters. Let's open up our user parameter window and start typing in some stuff. I'm going to have a thickness, of course. I like to make mine 1.5 millimeters. I like to have a gap, which is the clearance between surfaces that are going to be touching. That is normally 0.2, but we can adjust that later. Let's go ahead and create a case diameter. Let's make this 60 for now. Again, we can change that later. Let's have the case height as well. Let's make this 15 millimeters. Why not? We can change it later. So I got the case height, the diameter, a gap, and a thickness. One last one is the snaps, and I want my snaps to be 2 millimeters in length, or maybe it's tallness. We'll change it if we need to. So those are the standard parameters that I like to create before designing, because I tend to use those over and over again. All right, I'm gonna create the first sketch in my bottom cover. So let me go ahead and activate that, create a new sketch. I'm gonna sketch here on the bottom foreplane. This is all gonna be driven from the center origin. So let's start from the center and then draw it outwards. Go ahead and type in our case diameter word and hit enter, and there it is. I'll select that, hit E on my keyboard to extrude, and instead of putting a number, I'm gonna say that's gonna be the thickness. Hit OK. That's pretty much all I need to do for this. Actually, no. Let's go ahead and start creating the snaps. I'm going to create a new sketch, and it's going to be on one of these side profiles, whichever way you'd like to. You might want to look at your view cube, like is this the front? Do I want mine to be in the back? I'm going to make it on the left and the right side, so I'll start from there. Let's zoom in here and start sketching out our triangle. So let's go ahead and make a triangle. It's going to look like this. All right. And then we're going to start straightening it out. So this edge here already gave me a sketch constraint, which is horizontally and vertically constrained. And then I will create a sketch dimension, a degree, saying I want a certain degree from these two edges here. Let's round this off to 45. And then we can select these 2 points here, these 2 edges rather, and then set a perpendicular constraint to that. That way it is a nice and 90-degree thing here. The last thing I'll do here is give this line a sketch dimension value of the snaps, and that's going to be 2 millimeters because we set that up. Now I have this triangle that I can move around, which is nice. Now to create the rest of the shapes, it's going to look like this. We're going to make a straight line that goes across, and then a line that goes up this way, and then one that goes back down connecting to one of these points here. So to straighten this out, I'll select these 2 lines and create a perpendicular constraint there. And then all I need to do here is give this edge here, this line, a thickness, a value of the thickness, and that's 1.5. Okay. So from here, now we can kind of move this whole set of lines that creates our snap fit shape. And I need to start adding some sketch dimensions to it. So starting from the center, I'll create a sketch dimension, hit D on my keyboard, and then select this bottom line here. And I just need this 2.5. I need to change that to the thickness. And hit OK. So now it is, if we look at it straight on, you'll see there it is right there on that thickness. And then what we can do is you can grab this line and say, I want this line to be a certain distance away from the center. And this is going to be our radius of our diameter. So we'll take our diameter, divide that by 2, and then we need to subtract the thickness from that. And we're doing that because when I create the case, I'm going to have it go, I'm going to make an offset that will create the wall. So that's why I have this little bit of extra gap here. So I'm subtracting the thickness, the wall thickness really, from that. So now that that is set up, I can now hit Finish Sketch. And the way we're going to curve this around is with the Revolve tool. So I'm going to hit the Revolve, and our profile will be just this thing here. Not the inside, but just this shape here. The axis will be our blue line here, which is the Z-axis. And I will change the direction from one-sided to symmetric. And normally this would be like 360 degrees, which is going all the way around. But for you could do that for your case if you'd like. But you would have a free spinning top cover, or at least it would be able to be free spinning. You might not want that, so in this case I'm making it 30 degrees. And again, I have that direction set to symmetric, because if it was one-sided, it's only going to go one side, which makes sense. On the operation is set to join, so that it merges with that body. Hit OK. All right, so that is our first snap bit. And what I'll do is I kind of want this one to be mirrored to this side. So we'll just bring up our mirror command and change the pattern type to features and select our revolve from the timeline. Our mirror plane will be the plane that makes sense. In this case, it's this one right here. You get a little preview there before you hit OK. Hit OK, and there is our bottom. All right, that's our first thing. Let's go ahead and create our case. So activate that component. And what I'll do is I'll create an offset plane starting from the bottom here, and then going up. Instead of a number, I'll just type in thickness, because that's the value that we want, is to be our thickness. I'll select that construction plane and start sketching right on there. Again, from the center, we'll create our circle. Let's call this the diameter. And then what I'll do is select that circle and then hit O for offset. And I want the offset to go inward, so that is a negative value. And I want it to be the thickness, of course, so I can say negative thickness, and that will give me that 1.5 millimeter value, and hit OK. All right, so now I'll hit OK, finish sketch. I'll select just that sliver of our wall thickness, and I'll hit extrude. I'll start to bring this up, but instead of using a real fixed number, I'll go ahead and type in thickness, height, because we did set that up already. So the height is set to 15 millimeters, and OK. OK. I can hide the sketch for a second there just to kind of get a look at it. All right, the next thing I'll do is I'll use the mid plane tool to create a mid plane between the top surface of our case, let me hide the bottom cover, and the bottom surface of our case. And that'll, in Fusion, we'll just figure out what the center of that is. So there it is, and it'll always update whenever we update our height value, our user parameter. Sweet, and that'll help us create a mirror in a few moments as well. So with the case selected, we need to create our nubs, and the nubs should have the same orientation of our snaps there that we created. Let me just go ahead and hide that real quick. And so that means we're going to create it on this surface here, on this plane, and then we can come in here and start to create our triangle shape. So let me hide the bodies for a second. The triangle shape is going to be inward, so we'll have a straight line, and the point will come out this way and then connect back again. All right, so we already have our vertically set constraint there, so I'll just apply a dimension here for snaps. I'll create our degrees here, which need to be 45, and then I'll grab these two lines and make them perpendicular. Cool. Next thing is let's grab this this vertice here, and I say I want a certain distance away from the center right here, going up and down. Let's make this the thickness. And then this line needs to be a certain distance away from the center again. This will be our diameter divided by 2 minus the thickness. And that sets it right in there where it needs to be. We'll add the gap a little bit later. So with that there, let me bring back my body and hide our bottom cover. Look on the inside there. We're going to use the same thing, a revolve, and we'll revolve that profile on this axis, which is our blue line. And then I'll change the, there's a little bit of a bug here. It's the direction set to symmetric, but it's not showing me that. So I'm going to switch it back to one-sided and then switch it back to symmetric. And then Fusion remembers that that is what it should do. All right. Our degree should be about the same. So let me set that to 30 and operation set to joint. So I'll hit OK. With that there, I could bring back the bottom cover just to get a look at it and see that, yeah, that looks like it is indeed the same degree. Cool. The next thing is to create a mirror. So I'll hit mirror, and I'll mirror that revolve. And then our mirror plane will be this this construction plane there that got made. That's sort of built into the component. All right, so hit OK. And then we have those two nubs in there. Let me hide the bottom cover so I can see. And there we go. There is one over there and one over here. Excellent. Now the next thing we need to create is the geometry that's going to stop the cover from twisting open. So let me start doing some things here. I think I could just do S key to bring up the shortcuts and just say color cycling toggle. I'm going to turn that on. And sometimes it gives you decent colors. This time it didn't. I don't like the colors. So I'm going to turn that off and bring up my appearance window and then just assign some colors to these things because they just help me visualize it a little bit better. You can even edit the color to bring it up so you can see a little bit more of the detail. And that way I can kind of get in there. Another thing I'll do is I'll use the selection analysis to get a slice a sliced view of the half mark there, so I can see the inside of our mating surfaces there. So that's cool. All right, the next thing you need to do is create that geometry that's going to stop this guy from twisting open. So if I were to actually print this out, and you can see here that as I twist it open, this could be something that you want as a feature, but it's hard to tell where inside the case is it twisted open or not. So if you want to do that, you can, but in this case I want to have it not twist open. So I will create some new sketches just to create sort of a geometry that's going to stop that from happening. So I'm going to draw it and make sure that I'm in the right component, which is case. That's where it's going to go. I'll create a new sketch, and it's going to be on the opposite end here. So looking at this surface here, that's going to be on the front and the back. So here, all it's going to be is a rectangle with the snaps value. So that's going to be 2 by 2 millimeters. And then I just need to assign some sketch dimensions to it. So I can say for this surface to the bottom here is going to be the thickness. And then from this line to the center will be our diameter divided by 2 minus the thickness. And there is that. Hit finish sketch. Now that that is placed where we want it to be and drawn, I can create a sweep. The sweep, we're using a sweep because we don't actually want to revolve around the thing. We just want to sweep along a certain edge here. So hit sweep. And then what we'll do is we'll hide the bottom cover and hide the analysis for a second. And the path is going to be this line here. Now you see if I roll over it, the path is only the line that starts from this edge to the other edge there. So that is about all I want to do. Is to select it, you get a nice preview of it. You can see what it's doing here. It's just creating some geometry that will stop our snap fit piece from actually coming off and twisting out. So that's why we're adding this. So I'll hit OK. Now this is added, I just need to mirror that to the other side. That's simple enough. We'll bring up the mirror command and the pattern type set to feature. I'll select that sweep from the timeline, and then our mirror plane will be the one that makes sense here, this one here. Hit OK. And there, that looks good. Now there's some other things that we can do. I can add a chamfer to this edge here. Let's make it 2 millimeters, rotate around, select the same edge on the opposite end, hit OK on that. That looks good. Another thing I could do is add some fillets to these edges so they're not so rough and pointy. So I'll select those two there, rotate around and select the other two, give me a total of 4 edges. There we go, hit OK. So that is really nice there. Cool. I need to mirror this whole set of stuff to the top because we're going to have a top and a bottom. So it's really this one, these, all of that right there, starting with the revolve all the way down to the fillet. With all those selected in my timeline, I can just say mirror. And then Fusion says, oh, those are 6 selected. My mirror plane will be none of these guys because these are default. Remember that one that we created that was the midpoint? Well, we're going to use that one, which is right here. So select that, hit OK, and there it is. Let me go ahead and hide that constriction plane since we are done with it. So now we have a mirrored thing. And what's really nice is if we wanted to change the height, make it a little bit taller, say 20 millimeters, it's going to change perfectly with us. Let's drop it down to 10, make it even smaller, and that looks okay. Let's bring back the bottom cover and take a look at that. That looks okay. Now that we've kind of created this, let me go back into the bottom cover and start applying those offsets. So I need to create some offsets to give us some gap, because if we look at our section analysis, you can see that there's no gap. And if we printed this out, it'd be way too tight. It probably wouldn't fit. So what we'll do is we'll create a press pull of these surfaces, this one and this one. We want to bring these inward. And instead of having a fixed value, I'm just going to type in gap because we already set that up in our user parameters. And it's 0.2 millimeters. So hit OK on the gap. And now I need to hide my case so I can get to the other surfaces. I'm going to use a press and pull again, but this time on these surfaces. Let's get that one, revolve around and select the opposite ones here. All right, now instead of adding a value, I will just type in gap, but it needs to go on the inside. So I'm going to say negative gap, and that'll push it on the inside. Excellent. So now with that, I can bring back the case and take a look on the inside. Yeah, there's definitely a 0.2 millimeter distance between those surfaces. And that's what we want because we're 3D printing it. Another gap that you want to do is this surface right here, because you can see here that this surface and this surface over here are just touching. There's no gap between them. So let's go ahead and add that gap between them. And turn off section analysis for a second. So again, a press and pull is just fine. So I'll select this edge, surface, this other surface. Instead of automatic, sometimes that happens. I'll create new offset. And then I can select all these multiple surfaces like that. Did I call them surfaces? I meant to say surfaces. And negative gap, because we need them to go on the inside. So you can see here, as I hold down the command key, I can see a preview of what the effect is being done. I'll hit OK. Now if I bring back the case, we should have some gap all the way around. Looking at it straight from the top, we can look down into there, and yep, there is a slight gap that we want. Excellent. Well, at this point, we could redraw the bottom cover, but if really this was to be a simple case as is, I can just mirror that entire component. So I say mirror, change the pattern type from features to components. This will be the thing that we're mirroring, is the bottom cover. And then our plane, well, it's going to have to be that midpoint construction plane that I think is hiding inside the case. Yes, it is. So let's select that and hit OK. And then hide the construction plane again. So there it is. There's our top and our bottom. We can even call it top cover mirrored, because I did create that thinking that we were going to make it, but let's go ahead and delete it and say, no, we don't need that. That is a really short way to create it. And if we look on the section analysis, we can get a good look on the inside there and see that all our surfaces are nice. Now you might be wondering, why isn't there a gap between this top surface and this surface here? Well, because we have a gap just about on the top and bottom, you have plenty of room to kind of make this. I think if we were to add another offset to this surface, we might have too loose of a tolerance. So if you do want that, I guess you could do that. But for my testing and my projects, I tend to make these tend to work out just fine like that. So a bit weird on what happened here. There we go. Okay. It was just the way that everything got moved. So not a problem there. All right. Well, that is a really quick way to create these snap fit geometries for a circular case. Now, what's really cool about this is, of course, we can change the height, change the diameter, do all that stuff, and it will just blend with it. It'll just adapt and grow with it. If we wanted to change the size of our snaps, we can do that as well. Let's increase that 2 to a 4. That way we have these really chunky snaps. If we want it to be a little bit thicker, maybe 3 millimeters, we can do that as well. And that is making really chunky and nice. Now you might want to adjust your chamfers and your fillets there. That chamfer doesn't cover that whole bit there, so we would have to change that from a 2 to a 4 or whatever. Perhaps we can go into the chamfer and say, instead of the 2, we can say it's the snaps, and that'll always update now. So that's cool. We can change this up as much as we want. Wow, that is looking really sweet. What is the thickness? 1.5, yeah. And then the height back down to like 10. Very fun to play with the values and just get a completely different design almost. Hopefully that is entertaining and enlightening. Thank you guys. Let me know what you guys think of this one. I always appreciate your guys' comments. And don't forget that if you do want to build this project, it is a really fun one. Check it out. Not too much soldering involved, especially since the feather already has all of the sensors built into it. So that is really awesome to have. I hope you guys have a really good week. Let me know what you guys think. I will see you in the next one. But until then, remember to stay safe and make a great day. Thanks, folks. Bye.